So, allow me to define what sigma notation is. Definition of sigma notation. Yan. So, gagamit tayo dito ng Greek letter na tinatawag na sigma, of course, kaya nga siya sigma notation. So, yung sigma notation natin, ganito yung tsura niya. Ay, then, maglalagay tayo ng expression dito, f of I. Okay? Kahit anumang variable ang pwede nyong gamitin. No? Pwedeng G, pwedeng H, wala namang kaso dun. Then, lagay tayo dito ng I equals M sa baba ng sigma and another variable sa taas naman. Okay. Pag nakakita kayo ng ganito, kailangan mo lang is mag-add ng mag-add. Okay. So, paano ka mag-add? Saan ka magsisimula? Magsisimula ka sa M at magtatapos ka sa variable or number na nasa taas ng sigma. At this case, meron tayong variable n. Now, kung mapapansin nyo, we have I equals to M, meaning, ang pinapagana natin dito ay yung variable I. So, pag ganito, start tayo sa M. So, we have f of M, since dito tayo nag-start, plus, mag-a-add ka ng kasunod ng M. Yung kasunod niyan, yung whole number, ay f of M plus 1. Susundan natin ng f of M plus 2 plus f of M plus 3 plus dot hanggang makakating tayo sa dulo, or let's say hanggang dun muna sa second to the last. We have f of n minus 1 hanggang f of n. F of n meaning ito yung last term natin na kailangan i-add since n is the variable sa upper part ng ating sigma notation. Now, papangalanan natin yung mga nilagay nating letters. So, M, ito yung ating lower limit. This is our lower limit. N is our upper limit. And I is the index. So, ito po yung ating sigma notation. Provided, dapat, where M and N are integers, okay, and at the same time, the lower limit should be less than or equal to upper limit. The index of summation can be any letter, hindi lang I. Pwedeng K, L, M, depende kung ano ang gusto mo. No? Halimbawa, bigay tayo ng ating first example. Okay. Yan. We have the summation of K squared, K plus 1. Right? Then, since K ang ginamit nating variable, K din ang gagamitin natin doon sa baba ng sigma. K equals, lagay tayo ng numerical value, let's say 3, then 6 dun sa upper limit. Now, pag binasa natin to, ang sasabihin natin is summation of K squared over K plus 1, where K ranging from 3 to 6. So, paano yan? Sabi natin, mag-start tayo sa 3, magtatapos tayo sa 6. Yun yung isa-substitute natin sa variable K na meron tayo. So, this is equal to 3 squared all over 3 plus 1 plus 4 squared over 4 plus 1 plus 5 squared over 5 plus 1 plus 6 squared over 6 plus 1. Okay? Yan. Pwede tayong magdagdag ng example. Let's say, the summation of a sub m, where m ranging from 1 to 7. Okay? So, ang gagawin mo lang dito is mag-add ng mag-add. Start ka, of course, sa ating a sub 1. Since 1, yung value ng ating summation index. No? A sub 1 plus a sub 2 plus a sub 3 plus dot until we reach a sub 7. Or in calculus problems, no, marami kasing bagay doon na kung saan concern mo yung area, kaya pwede natin tong isingit, no, yung A, that means area. Nag-a-add ka ng mga areas. Now, gate tayo, let's say yung may mga delta. Okay. So, say we have the summation of f of x sub I, x sub I, delta x, where I ranging from 2 to 7. Okay. So, ang gagawin mo lang dito, masyado mataas yung 7, siguro gawin lang natin gawin lang natin 4. Okay. So, ang gagawin mo lang dito is palitan lang yung I ng numerical value na mag-i-start sa 2. So, we have f of x sub 2 times delta x. Since wala namang I doon sa delta x, wala tayong ipapalit doon. Ay, plus f of x sub 3 delta x plus f of x sub 4 delta x. So, ganun lang kasimple yung ating sigma notation. Okay. On our next topic, we're going to state some theorems under sigma notation and magpo-prove tayo ng mga ilan dun. Okay. So, punta tayo sa mga theorems. Okay, let us have our first theorem. Okay. Sinasabi sa theorem na to is nag-a-add ka ng mga constant. No? So, you have C, constant, where I ranging from 1 to n. Okay. This is equal to what? Any idea? Let's say we have C is equal to 2. Okay. So, we have 2 plus 2 plus 2 plus 2 plus 2. Let's say 5 lang. No? This is also equal to 5 times 2. So, yung 2 is imumultiply mo sa isang numerical value at yung value na yon ay kung ilang beses mo in-add yung 2 sa sarili niya. So, let's say you are adding 2 4 times, no? 4 times. So, this is equal to 4 times 2. Or in general, you are adding 2 n times. So, you have n times 2 or 2n. Right? So, the summation of C, where I ranging from 1 to n, is equal to Cn. Okay, next theorem. Meron tayong summation of C times f of I, where I ranging from 1 to n. This is equal to C times sigma of f of I, where I ranging from 1 to n. So, paano kaya nangyari yan? Okay. Bigyan natin ng proof. Okay, proof. Okay. Dito, start tayo dito sa left side, gagawin nating right side, no? We have sigma of C times f of I, where I ranging from 1 to n. This is equal by sigma notation definition, we have C times f of 1 plus C times f of 2 plus C times f of 3 plus all the way up to C times f of n. Right? Now, since C is present at each term, so meron tayong C, C, hanggang kay nth term, pwede natin siyang i-factor out. So, mangyayari, magkakaroon ka ng C times, okay, f of 1 plus f of 2 plus f of 3 plus all the way up to f of n. Okay, so finactor out lang natin si C. Okay, now, this is now equal to C. Yung nasa loob ng ating bracket, okay, ay pwede nating sabihin siya yung sigma of f of I, where I ranging from 1 to n. And this proves our second theorem. Para sa ating pangatlong theorem, okay, meron tayong summation of f of I plus g of I, where I ranging from 1 to n. Okay? This is equal to summation of f of I, where I ranging from 1 to n, plus summation of g of I, where I ranging from 1 to n, no? 1 to n. So, paano natin ipoprove to na equal lang po ito sa isa't isa? Okay? Ang kailangan lang natin gawin ay express itong nasa left side gamit ng ating sigma notation definition. Okay? Then, gagamitan lang natin ng onting algebra. Okay? So, ito, yung nasa left side, okay, that is equal to, paano ba? Okay. F of I plus G of I, where I ranging from 1 to n, is equal to F of 1 plus G of 1. Okay, lagyan natin ng bracket dito. Plus F of 2 plus G of 2. Okay. Plus F of 1, sorry, F of 3, no? F of 3 plus G of 3 until we reach F of n plus G of n. Excuse me. F of n plus G of n. Okay. Ngayon, since they are separated by addition symbol, nagko-commute yan dahil commutative ang addition, right? So, pwede natin itong i-equate as f of 1 plus f of 2 plus f of 3 plus hanggang makakating tayo kay f of n. Okay? Then, ikulong natin sa bracket plus another set of bracket. At this time, ang nasa loob ay g. G of 1 plus G of 2 plus G of 3 plus hanggang makakating tayo kay G of n. Okay. Ngayon, yung first set of bracket ay kinocompose ng ating variable f. Okay. So, pwede natin yung gawing summation of f of I, where I ranging from 1 to n. Then, yung second set ng bracket ay panay G lang naman ang makikita natin. Kaya, pwede natin yung i-express as summation of G of I where I ranging from 1 to n. Ngayon, napakita natin na equal ito sa isa't isa. And there you have it, our third theorem. So, itong third theorem is also applicable kung papalitan natin ng subtraction sign itong addition sign, no? So, mangyayari lang, mawawala yung ating addition sign dito sa right side natin. So, subtraction sign din po yung nandito. Okay. So, that is our fourth theorem. Okay. So, gawa tayo ng sarili niyang section, no? So, plus to. So, addition po yan. Okay. For our fourth theorem, okay. Okay. So, meron tayong summation of f of I minus g of I, where I ranging from 1 to n. So that is equal to summation of f of I 1 to n minus summation of g of I, where I 1 to n. And the proof is left as an exercise sa ating mga students. Same lang din yung process para sa third theorem. Nagbigay tayo ng example. Halimbawa, let us try to evaluate or let us find the sum, no, ng mga summation na makikita natin. Okay, find the sum. By using the above theorems. Okay, number 1. Hanapin natin yung sum ng 3i minus 2, where I ranging from 1 to 6. Bawa, ganyan, no? By fourth theorem, di ba? So, by fourth theorem, ano yung fourth theorem? Ito yun, no? Yan, ito yung fourth theorem natin. So, applicable yan. Okay. Mangyayari, magkakaroon tayo ng summation of 3i, where I ranging from 1 to 6, minus summation of 2, where I ranging from 1 to 6. Hindi lang siya fourth theorem. Makikita nyo, may constant tayo na 2 dito sa ating last term. So, pwede natin i-apply dito yung ating theorem 1. Okay? First theorem. The summation of C, where C is any constant. No? This time, ang constant natin is 2. So, ito, mangyayari dito, magkakaroon tayo ng 3 times 1 plus 3 times 2. Sorry. May sumobra. Plus 3 times 3. Plus 3 times 4. Plus 3 times 5. Plus 3 times 6. Okay. Then, gawin ng bracket para hindi ka malito. Minus. Another bracket. Ito naman yung ating isa-solve. Since constant ito, that is equal to Cn by first theorem, magkakaroon tayo ng 2 times 6. Ay, 2 times 6. So, ganyan na lang kasimple. Kaya, evaluate lang natin. We have 3 plus 6 plus 9 plus 12 plus 15 plus 18. Okay. Minus 2 times 6 is 12. So, this is equal to what? 18 plus 15 is equal to 33 plus 12, 45 plus 9, 54 plus 6, 60 plus 3, 63. Minus 12, we have 51. So, the answer is 51. 51. Next example, number 2. Halimbawa, meron tayong summation of 3i plus let's say I, okay, over I, halimbawa ganyan, where I ranging from ibahin natin, gawin natin 2, no? 2 to 5. Ayan, ganyan lang. Okay? Kung mapapansin natin, yung numerator ng fraction ay may I. So, pwede natin yon i-factor out. So, mangyayari, mag-aaroon ka dito ng summation of I times 3 plus 1 all over I, where I ranging from 2 to 5. So, maka-cancel na yung ating I dito. Okay. Kaya mangyayari, magkakaroon na lang tayo dito ng summation of 4, where I ranging from 2 to 5. Okay? So, this is equal to, by theorem 1, okay. So, ilang beses mo yung multiply yung 4 sa sarili niya? I mean, i-add. So, start ka sa 2. So, you have 2, 3, 4, 5. 4 times. Kaya, meron kang 4 times 4, which is equal to 16. Ito yung sum ng ating problem. Okay, let us have our last example. Let's say we have the summation of k over k plus 3, where k ranging from negative 2 to positive 3. Okay. Take note sa definition natin, sinabi natin yung lower limit is always less than or equal to our upper limit. No? Mapapansin natin sa ating mga first or sa ating mga examples, lagi mas mababa yung lower limit sa upper limit. Okay. Lower limit sa upper limit. Okay. Lower limit sa upper limit. So, this is equal to, start tayo sa negative 2. We have negative 2 over negative 2 plus 3. Okay. Plus negative 1 over negative 1 plus 3 plus 0 over 0 plus 3 plus 1 over 1 plus 3 plus 2 over 2 plus 3 plus 3 all over 3 plus 3. So, let us try to simplify this one. Sa first term, we have negative 2. Okay, negative 2 over 1 plus negative 1. So, this is positive 2 sa denominator. Meron tayong negative 1 half plus 0 plus 1/4 plus 2 fifths and plus 3 over 6, no? Or 1 half. That is 1 half. 3 over 6. 1 half. Okay. Simplify. You have negative 2 plus 0. Okay. Negative 1 half plus 1 half. So, mawawala na to. That is 0. Then, plus 1/4 plus 1 over 5. Okay. So, 0 na din to. Kaya, ignore na natin tong part na to. Okay. Yan. So, bali ito na lang yung ating pinag-uusapan, no? So, lagay natin dito. Commutative naman ng addition, di ba? Okay. So, to find its sum, meron tayong 1 dito. So, ang magiging LCD natin dito ay 20. Is that correct? 20. So, 20. 20 times 20 over 20 to, no? So, we have negative 40 over 20 plus 4 over 20 plus 5 over 20. Okay? So, pare-parehas na yung ating denominator. Magkakaroon tayo ng negative 40 plus 4 is negative 36 plus 5. We have negative 31 over 20. So, ito yung ating sum.